Welcome to This is Concrete, a podcast where we speak with the people whose work revolves around concrete and coatings. Let's get to what you came for.
All right. Hello, this is Chad Gill. I am the host of the This is Concrete podcast, where I talk with leaders in facilities management, architecture, contracting, and more. This episode is brought to you by Concreate. Concreate is a concrete polishing and coatings company with nearly 20 years of experience working in commercial, industrial, and residential markets. So whether you need smooth transitions for warehouse traffic, a show-stopping lobby floor, or a seamless concrete accent wall, we can provide the skill and imagination you need to make your concrete uncommon. So what are you waiting for? Visit us at thisisconcrete.com and learn more about Concreate today. So joining me today is Levi Smiley, who is constantly smiling from what I can see, a long-time Blast Track employee, product manager for Blast Track brands at Husqvarna Construction Products. He has almost 25 years of experience in the surface preparation and an in-depth knowledge of concrete prep and equipment. Interesting. I love this, that he got into the field. He would start out in the field as a kid, where he was a helper or a broom technician. I like that. That's right up there with sanitation engineer, I think.
That's exactly right.
That's a good one. I haven't seen that one yet, but I'm damn sure going to use it. Awesome. Thanks, Levi. I really appreciate you coming on and talking to us about surface prep and what we're doing. So I guess, so you started out in the blasting and painting industry. This is with a family business. Is that right?
Yeah. So first off, thanks for having me on. Appreciate the invite. Excited to be here. I was exposed to the industry as a kid, so I'd been around the products and the process for decades before I actually started getting paid in the industry.
As my dad would say, you got to eat tonight, right?
Yeah, that's exactly right. So I'd always been around it, and when it came to junior high and high school, just popped into the shop with my dad on the weekend or late in the day and kind of got the feel for what it all was. So it was a really easy transition for me when I was of legal working age to obtain a paycheck, start physically doing the work. And there was a much shorter learning curve in doing so. So I'd been around it longer than the 25 years I've been paid to do this.
Exactly. That's right. So we were talking before about surface preparation. There's lots of ways to do it, lots of cool tools, everything from hydroblasting to shot blasting to grinding to milling and those kind of things. And today we're focusing mostly on shot blasting, but also, grinding, shot blasting, how they work together or don't work together. Is it an either or situation, or how do you look at these?
Fantastic question. One of the things I added to the Blast Track University class that I helped develop is we really do try and follow the specification for the manufacturer's product that you're going to put down, and then follow ICRI's CSP profile that exists. So specification does drive a lot of what we're doing. However, if there's no specification to follow, typically if coatings are going to be applied to that concrete substrate that are 15 to 20 mils in thickness or less, you're going to grind. Anything thicker than that, you're going to blast. Just as a general overview, that's kind of what you follow. But it also has to do with the condition of the floor, right? If you've got a lot of floor verticals or minus surface area, divots, spalls, chips, joints, cracks, concrete grinding as a technology isn't really able to get into those vertical areas, and that's where you need to physically vertically propel steel shot at them to clean them out. So sometimes the floor is always talking to you. You just got to learn to listen to it, right? So what's being presented to you, you have to understand how to process right, mentally, and be able to choose what technology to employ at the right time. So generally speaking, any floor is going to need to blast all your minus surface area, and then you can come back and topically smooth the floor and prep it for a diamond grind if that's the profile required. So one of the things I'd like to drive home in that training class is, after you analyze how grinding works and how it interfaces with the substrate and the profile left behind, do the same thing for blasting. You start to realize that they're not competing technologies. They are, in fact, complementary technologies to one another. They're never going to replace one another. They do the thing they do, and they do it very well. But it's up to the operator or foreman or the guy driving the work on site to choose the right one at the right time.
So when you're talking about 15 and 20 mils, why is that the break point when you shift from grinding to shot blasting?
Perfect follow-up question. When you shot blast
I've been practicing for this, man. I was like,
doing great at it. The reason that's kind of the line is when you shot blast a floor, you have to overlap your passes, and that overlap line now is blasted twice and sits deeper recessed in the floor. So if you don't have a product that's going to fill in that overlap line, you see that line come through or translate through the material on the floor. So after you blasted a floor, you stand at the end of that floor, that driveway and that garage floor, and you look at the garage, you're going to see those overlap lines. They call them cornrows or tiger striping. So those will translate through a thin film system. So if you're going to put down a stain and a sealer or just a clear coat, shot blasting looks horrendous on that floor. So that's where you would employ more of a diamond grinding profile, because you're smoothing the substrate wall to wall, edge to edge, and you're giving a nice clean canvas for that artist to come in and lay that design or that beautiful painting down, right? So when you get to that higher mill system, you're looking for more bite, more amplitude, a better surface profile to be able to mechanically bond to.
Yeah, that makes total sense. And that's so when you're doing the, let's say you're going to do, like, when is a time when you would do both?
I had a short stint as a contractor here in California. Every floor that I did, I was utilizing both technologies. There is always minus surface area in that floor. There is always something deep in that substrate that a grinder can't get. In my humble opinion, I would say that every contractor should own a 110 volt 8-inch shot blast machine to have on site. You can go out and just hit those little tiny areas that you need to patch or fill to make sure they're gonna stick right, and then come back and grind over the top. So as a habit, I was always doing both. Now you don't always, and that's just for the general preparation before you layer coating down. When it comes to coating work, it's really the thickness of the coating or the specification really dictates which one you're gonna utilize.
Sure. And so when you're talking about shot blasting, so grinding is about texture in my mind. You know, it's like, hey, I want to get the floor smooth, get the lumps and the knots and the scratches out, so that when I put down a coating, it's smooth. You know, it lays out nicely and stuff like that. And certainly the cornrow thing that you're talking about. Shot blasting is much more about trying to do a terrain. It's like you can clip all the peaks off of the mountains, but shot blasting is about cleaning out all of those valleys. Is that accurate?
That is accurate. Yeah, and the machine will go over those undulations in the slab. It's never going to level like diamond grinding or concrete grinding can do, where you're going to take over just some high spots in the floor or go over your joints or uneven cracks. That's what grinding excels at. Shot blasting is just going to go over those without leveling any of them. So it will go over those high spots, but yes, it does an excellent job of getting into those valleys. That's a great way to look at it.
And is that why shot blasting is typically shot blasting is fast. I mean, you can shot blast very quickly, and I guess maybe there's degrees of shot blasting too. Like if you're de-dusting or a brush blast all the way up to, I don't know what is called, I know you can get to the point where it looks like somebody put a paint roller down. That normally means the guy got a phone call while blasting. But yeah. And what are those degrees, in blasting as you're trying to go through there?
So you've got, as far as speed is concerned, to your first point, when you get to the largest diamond grinders in the industry that are standard that every contractor is going to run, that's a 30-inch machine. So they're going to be electric or propane. That's going to yield you approximately 1,000 square foot an hour, 1,200 square foot an hour on a good day. With the right PSI slab and the right diamonds on there. It can be slower if your concrete's a little bit harder. But shot blasting, a 30-inch grinder is about as large as you're going to get. They do make larger ones out there, but that's on average what you're going to use. A 10-inch shot blast machine, which is the second smallest size, is going to yield you 2,000 square feet an hour. So it's double immediately.
Right.
You then go 15-inch, 20-inch, 30-inch, and they just exponentially get faster. You need more electricity and voltage and understanding of the process. But we make machines that'll get up to 20 to 30,000 square foot an hour in blasting. And this is bridge and highway applications and much larger square footage when you've got it all laid out in front of you. But blasting can be significantly faster in doing that. So there's also machines that are designed for removal applications and other machines that are designed for brush blasting. So it's also not just fitting blasting versus grinding, but making sure you're getting into the correct machine for the application that you're in as well.
So when you're talking to a customer, like, yeah, we're going to come in and shot blast it. You're thinking about, yeah, we're blasting concrete. Okay, I know we're not blasting concrete, but what is it looking like? How controlled is this process? Dust, debris, steel shot flying around. What is that? What is that? Is it pretty contained?
It is pretty contained. So I'll kind of walk you through the way we explain this technology to the customer and kind of what their responsibilities are. There's a lot of moving parts in blasting, so it's a lot different than putting diamonds on a grinder and just letting it spin on the floor. Grinders are very forgiving when it comes to that, where blasting is not. So understanding the process and what your job is as the operators is very important. So it's a pairing really of two pieces of equipment in the walk by and stuff. You're going to have a dust collector and a blast head. The dust collector is designed to match specifically with that piece of equipment. So it's done under negative pressure, and that's really what makes the machine work properly. So you'll have those two pieces hooked together via a hose and an electrical cable. So the blast head's getting all its power and suction from the dust collector that way. The operator controls is most imperative, where the operator is going to need to understand that he's solely responsible for the shot size selection, the metering of the abrasive, the proper overlap of it, and then gauging your impacts per square inch by your speed control. So all of those things are going on at the same time for that guy to be able to get a good blast on that substrate.
So probably more technical than other people would. The engineer in me wants to know. So how are you propelling this blast media to the slide?
Again, great follow-up question. So you have the blast machine. There's a hopper. That hopper is where all your steel shot is stored. And we're using steel shot for a very specific reason, because it holds kinetic energy. Inside, at the bottom of that hopper, is a valve that is opened and closed by the operator behind the machine. Now, it's not open all the way or closed all the way. He's metering that abrasive, so it can open a little bit or a little bit more. So he's telling the machine how much shot's going to be going through it. There's a maximum and a minimum with a dial or a gauge on the machine. So that shot falls down a little feed spout and then goes into the blast wheel. That blast wheel is powered by an electric motor, and it is propelled to the substrate. When that steel shot hits that surface, it removes the coatings or any latents on the concrete, and then rebounds back up through a rebound housing. So when it hits that substrate, it releases that kinetic energy and then bounces back up inside the machine. As it approaches the top end of the machine, it gets into an air wash separator, where the shot is completely stalled. And if it's heavy enough to be reused, it falls back down in the machine and repeats that cycle anywhere between 8 and 15 times a minute, depending on that piece of equipment. All the dust and debris that was generated gets sucked out to the dust collector. Eventually, that steel shot's going to round out and will get small enough to where its specific gravity is the same as the dust that's being generated. Then it too gets sucked out by the dust collector and rendered as waste.
I don't know about a good question, but that's a damn good answer. Good job. It's like, well, yeah, 20 years I'm working on it, man.
Yeah, right.
I can't answer that question, it's probably not it. But no, that's great, because it kind of explains, it's why do you need different sizes of shot?
Perfect. Different size shots are going to do different things. So the larger the shot, the more of a cannonball you're throwing at the floor and the more aggressive removal action that you have. But you have less impacts per square inch because of its larger size. So the smaller size shot you're going to be able to fit more in 1 square inch. So it's going to give you more of a brush blasting or a cleaning action. So if you have a coating on the floor you're trying to rip up, a 460 or a 390, which were the two shots on the higher side, on the larger side of things, would probably be the best options for you. If you've got a brand new slab that's poured 30 days ago and you're going to be laying an epoxy on it, you don't need that large size shot. That smaller size shot is just going to break through the cream, open it up, give you that CSP 3, 4, 5 that you're looking for, and you're on your way.
So we've used steel brushes. We're trying to brush out a crack or something like that, and it leaves that kind of carbony residue on the surface that's kind of like a bond breaker. And then, of course, we switched to bronze brushes. But why doesn't steel shot do that?
Steel shot, because you're not rubbing the surface, you're just impacting it quickly, so there's no residue left behind. Also, in a shot blast machine, there are 3 things happening. The first thing is the airflow inside the machine, because you have the dust collector hooked up to it without the machine running to start. So that airflow is beginning first. Then when you introduce the shot to the machine, your dust is the next lightest thing. So it's being sucked up in that airflow. And then behind that is the shot that's the heaviest thing. So as that shot is impacting the surface, anything that's lighter than itself, which is everything underneath it, gets immediately extracted from the substrate.
And the outside edges of the bottom of the machine, they're in order to create that seal, they're actually magnets, and the shot kind of seals itself. Is that right?
Yeah, you are correct. So it's a dual sealing system. So we have magnets that are affixed to the housing, and then you have either a brush or a rubber sealing system that goes around the outside of that to help contain the shot as well. The magnets sit recessed and sit a little bit higher from the housing itself. And you're absolutely correct. What we'll do is pack on brand new shot to get the level of the shot from the base of the magnet to the very bottom of the brush or the seal, and make sure that it is sealed in the concrete properly. What you'll find is when you go over a high spot in a floor or go over a joint that may be a little uneven, the machine may try and stall out on you, or you'll hear that magnet drag across that high spot. That shot will be drug off, helping the machine seal itself. That shot will be left on the floor. It can be picked up and reused, but during operation, shot will reattach itself to those magnets to make sure that it's still sealing to the floor.
That's pretty. Can you only do shot blasting with steel? I mean, there's sand blasting and soda blasting and dry ice, but shot blasting is what we're talking about. Is that strictly done with steel only?
Man, you're taking me back to 20 years ago now. I was part of what Blast Track was before was a whole industrial painting, blasting and painting as well. So I'm very familiar with all the products you just mentioned. Garnet, slag, baking soda, walnut shell, corn cob, aluminum oxide, none of it holds kinetic energy like steel shot does. So when it hits the substrate, it's just going to either shatter like shrapnel or not rebound back up. So you can only use steel shot in a shot blast machine.
Makes sense. And but what you did talk about is you're going to consume shot. You don't buy a 50-pound bag and use it for the rest of the year. I mean, you're definitely consume shot across there, much like we're consuming diamonds. You're running through shot as well.
Yeah. So a bag of steel shot is 50 pounds. You're roughly $50 a bag on average on a smaller 8-inch machine. And you're physically blasting, not dedusting, but you're actually utilizing it for blasting prior to grinding. You're going to have 3,000 to 4,000 square foot of bag. On your larger machines that are self-propelled with a larger horsepower, which is cycling more shot per minute, you're going to be 2,000 to 3,000 square foot of bag. Is longevity of it. The abrasive consumption for the machine, depending on the horsepower of the motor, anywhere from 5 pounds to 20 pounds an hour.
Oh, okay. So when we look at a steel shot chart, we start all over here. What's the finest that people typically will use? Like, is that a size?
Yeah. So there's 5 sizes. So going from small to big, you're going to be 230, then 280, then 330, then 390, and finishing with 460.
And the 460, I'm trying to even do light coating removal or really aggressive. What's the CSP concrete surface profile that we could get out of that?
460 we commonly use. It's not typically used on concrete. We're doing more steel blasting on naval vessels and maritime work, or in petrochemical markets when we're doing steel tank floors or steel tank roofs, and that's mixed with steel grit in particular. But that's really aggressive for tearing up coatings on steel, or on your bridge deck blasting machines for highway overpasses. We're using much larger equipment, and the concrete that's on that bridge doesn't have a cream on it already, so there's already exposed aggregate. So we're removing paste from around that aggregate and cleaning that substrate. So we're automatically leaving a 5 or a 6, in some cases a 7. So we're really able to get in there and prep that surface.
Do you ever mix medias? Like, do you have like 2 different sizes running at one time?
Funny you should ask. We don't mix it off the go, but what happens over time is on the electric machine, as you're running the machine, you were opening up, you're metering that abrasive, and as you open up that valve to the same spot you did for the last 20 or 30 passes, you'll notice that you're not getting as much shot going the machine, so you're going to have to open it up a little bit more. At that point, you need to add shot to that machine. So it's not completely empty, so there's some in there already. But you say you started with 390, you add your next bag of 390 in the machine. What's left in the machine has already rounded out. So some of it's 280, some of it's 230 already. So it's getting to those smaller sizes as it goes through its life cycle. What that's called is an operating mix. So you automatically, after that first bag starting to wear out, you automatically get kind of the best of both worlds, where you have multiple sizes in that machine off the go.
Perfect. So I can buy 460, use it for a day, and then 280 and get my money right. It's excellent. I knew we'd find savings in this somewhere.
there you go. That's right. It's funny you should say that. We had a customer that did that, or a purchaser that was buying shot based on that ideology. What they didn't understand is they started buying twice as much epoxy to fill up the overlap lines in the floor. So there's
I bet. That's one of those times when you're walking past dollars to pick up pennies.
That's exactly right.
Yeah, man. When you're doing shop buys and you're running those things, it used to be, you could shot blast the entire floor, and then you're looking at, and you're still hand grinding your edges. Is that still the case? Are there edge shot blasters, or have they made adjustments to the machine where you get closer, or is it even not as important?
So starting with the last one, it's always important. Edge work is really how polishing guys get paid, right? And it's just as important for adhesion at entryways where things can walk off, the seam around the garage, or your entry point from a side door in a garage. So we have made our smaller 110-volt shot blast machines to where you're able to remove the magnet from the side, turn the handle and invert it, move the tire from the outside to the inside. So you're really able to get the machine up next to the wall, but it doesn't go all the way to the wall. In my mind, the most powerful surface preparation tool that can be yielded is a 7-inch hand grinder with a cup wheel. You're going to be able to get more done with it, and it's going to get you everything you need to do, right? And being a grinder, you can add PCBs or transitional things for polishing, any number of different metal bond cup wheels to be able to get that stuff. So I don't think we're ever going to go away from hand grinding. It's a necessary evil, but the smaller machines do get extremely close to the wall, but not all the way to it.
And I will personally attest to the idea that, yes, we have made, as an industry, we have made every configuration of an edge grinder that stands up, walks behind, does on everything. And we have yet to do away with 7-inch grinders.
Don't think it's going to happen.
You would think that we could do it, but for whatever reason, you just can't get rid of that 7-inch grinder.
Mm-hmm.
And it's a good tool, for sure. And then I don't think any shop, but when you're talking about dedusting a slab, that's, now you're talking about more of what you're calling like a brush blast. Let's say you're polishing, you're getting ready to grout a floor, or you're doing a real thin mill coating, so you've ground and now you just want to do a brush blast. Why is it so much cleaner than just a really good vacuum?
Great question. I think a lot of that has to do with grinding technology as a whole, right? And the dust collectors you're using with them. While you're grinding, you're really forcing all that dust back into the pores of the slab during the process. The dust collectors that attach to the grinding machines are built to run a higher static pressure or a greater lift and CFM to be able to pick up that stagnant dust that's on the floor, but it's not able to get it all up. So you can take a wand with that very high lift or high static pressure vacuum and try and clean that floor, but you've just mashed it into the pores so hard. Sometimes there just isn't enough lift with the vacuum that you have there to get it up off the floor. And then we talked about fundamentals of shot blasting here a little bit earlier. As soon as that piece of shot strikes that floor, it generates the waste and helps pick up anything that is on that floor and immediately puts it into that airflow in the machine and extracts it. So it's just able to do something different quicker than what a normal vacuum would.
Sort of like when we're trying to clean up dust, somebody you'll vacuum it once and then you broom it really hard and then you vacuum it again. Shot blaster's kind of doing that step in fades at the same time.
Right. No, you're absolutely right. And the speed of which it does it is incredible. Like your typical 8-inch 110 volt or 220 volt machine will yield you 250 to 300 square foot an hour of actual shot blasting. When you're dedusting, it's 1,000 feet an hour. I mean, you can knock out your small 2-car garage floor in 10, 15, 20 minutes. It's very, very fast. And that's quicker than you can actually vacuum the floor, right?
Yeah, that's it. And you can clearly see where you've been too. I mean,
absolutely.
It is shocking what the difference is from that.
And on the dedusting method, your proof's in the pudding, right? You can take your hand after shot blasting and wipe it on the floor, and you've got no dust. Do it after, wipe your hand on the floor after you vacuum the floor 3 or 4 times, and there's still dust on your palm, right? That's a bond breaker. That's inhibiting a coating from mechanically bonding that substrate.
And they're in a contractor alive who hasn't looked at that and thought, I think it'll soak through that.
That's right.
That's right up there with it's still tacky. What if I roll some extra hardener on it?
We need more buckets of B. Get it in there.
That's right. There's nothing worse than your guys calling and say, yeah, man, we had a bunch of B left over. What?
That's a heartbreaker.
We'll use it tomorrow. We better order it tomorrow. No, that's fantastic. That's and it's so one of the different times that I've seen shot blasting used, or we've used it as well, is when we're trying to get to an aggregate exposure job. We've actually broken the surface open with a shot blaster and then followed behind with grinding. And it just seems like shot blasting has the ability to get into harder concrete quicker than us trying to grind it. Is it just because it's impending and it's the way it works, or is there any reasoning behind that?
No secret. It's just the way it works. You're throwing steel at concrete. Steel's hard, really, really hard, right? Concrete is not, especially when you're throwing at the velocity and how much shot we're putting on that surface. So breaking through really hard caps is another application where that there's so much curing compound on that substrate, and you can't get a diamond in a configuration with enough edges on it or a matrix soft enough to cut through it, or it's just lasting 200 square feet. You put a blaster on there, it cuts right through that cream. You can make a bond switch to medium at that point, and the grinder does exactly what it's supposed to do there.
And is there what is blasting not good for? Like things that come to mind for me are things that have give, glue removal. But maybe I'm wrong. Sticky.
Oh, you're dead right. Absolutely right. So we spoke on steel shot and why we use it, which is it holding kinetic energy. So anything that is the technical term here, ooey gooey, thick and chewy.
There we go.
Yeah.
Hyphenated, just the last. That's right.
That's right. Anything that's ooey gooey, thick and chewy, shot blasting is not good for. Glues, mastics. Don't ever try and blast an elastomeric coating. All of those things will steal the kinetic energy from the shot and not allow it to rebound back up into the machine. So shot blast machines have their niche, but they also have their failures, much like grinders do. They're built for certain things, but they can't get others, right? So it's again, you start to see that painting that bigger picture where they're not competing technologies, they're complementary technologies, right?
Could you use a shot blaster? Say you're trying to bond to an existing coating and you're out of your window and you want to come in and just, something like that. Like I'm just trying to think of just unusual places where you've seen shot blasting used that worked well, but was kind of surprising?
Yeah, that's actually a great one. That's one that it's not super common, but you do get locked out of a building on a holiday weekend, or something came up and you're outside of that chemical cure window where some coatings 48, some 72 hours. You can. I'd suggest using a smaller machine. It's going to take you a little longer to do it. You don't want something with a large horsepower motor that's going to want to blast through the coating. So get something that allows the operator the ability to kind of go a little bit slower. You're going to use a very small shot, like a 230 or a 280, so you're getting a lot of hits per square inch, and then just kind of going over that coating to get that mechanical profile on it to be able to recoat it. That's a great one. Another one we talked about a little bit is really, really hard concrete. When you're going to be polishing a slab, you generally don't want to put a shot blast machine on it because of the chances of blasting holes in the floor and creating overlap lines that are just too much work after that initial blast. What we'll do is run a 15 or a 30-inch machine, and I'll get to why we run those instead of 10s or 20s here in a second. But you'll blast at a very high rate of speed with a very small size shot, and you won't overlap at all. What you'll do is intentionally leave a strip unblasted 2 or 3 inches over. All you're trying to do is texture that cream a little bit and cut through it to allow the diamonds to bite it. So that little strip that you leave behind, grinding is always trying to grind through the high spot in that slab. So it's automatically going to cut through that non-blasted strip and get down to the area that you did blast.
Yeah, that is one of the best lesson learns I've ever gotten. It is easy to, as a grinder, it's easy to take out a hill. It is very hard to grind to a valley.
Yeah, right.
Just so much easier. And it's a great way to get, an initial cut down and stuff like that, to open it so that your diamonds can really get a good bite in teeth.
Right.
But yeah, so that's perfect. I mean, other than you definitely can't shot blast wet.
No, that's a dry process only, friend.
Your vacuums won't like it, and shot won't like it. Nobody will like it.
No, not at all.
What are the common things where somebody you're like, hey, let me just mention these. Like the top 3 things are the mistakes that people make shot blasting.
Great question. Buying the wrong shot because it lasts longer. That is a real thing. Not putting your most comfortable employee behind the machine. You may want a guy that you have in mind to run that particular machine, but it's nuanced, right? And some guys don't get it off the bat, and they have a much longer learning curve in understanding shot size selection, metering the abrasive, speed control, how to get your overlaps right. What the longest path in the building is to blast. The machine's only working well when the abrasive's on the wheel. So if you're taking forever to turn around, or you're overlapping too much, a guy that isn't doing it right is probably leaving with a large machine 4,000 to 5,000 square foot of unblasted concrete a day. A guy that understands how to turn around and overlap, he is exponentially faster. So it's the comfortability with the machine and knowing how to master those little nuances on it.
Perfect. No, I think that's great. You can have all the best equipment, the best technique, the best ideas and stuff like that, but logistics, the idea of if you can go 100 feet down and 100 feet back as opposed to 50 and turn around, it is huge. The amount of time you waste. I mean, you could save almost as much time doing that as you can not hitting the gas station on the way to the job and back and at lunch and stuff like that.
Absolutely.
Pick up a lot of hours there.
You're absolutely right. And that's a contractor's biggest expense is time, is labor cost, right? So if you're able to shorten that with just a little bit of knowledge and information, I mean, it's a lot of saved money, and not just save money, but save time. You're able to spit out a couple, 3, 4, 5 more jobs a month just due to that alone.
Man, Levi, this has been great. I really appreciate it. I think that's all the questions I had. I was like, man, I was trying to make sure I asked everything I did so I could but yeah, we use shot blasting. We use it a lot. We use it for cleaning out cracks and divots. Sure. Anything that's got those kind of elevation stuff, I just think it's been a really good addition to our process. So I appreciate you kind of enlightening us on some more things. Sounds like I might need to go back and change a couple of things. Stop chasing that wet shot blasting dream.
Yeah, that's right. That's right.
That's
Well,
it.
I wanted to add a couple more things here. There's when it comes to blasting concrete and asphalt, there's actually two different types of machines. So you have your electric walk behind machines that hold a certain type blast wheel, and then you have your ride on machines that hold a different type of blast wheel. So your electric machines have a center fed blast wheel, which means the shot is coming down through the middle of the blast wheel, and that is controlled by a cage inside the machine that has a window in it. And that window tells that shot where to go on the floor. So as the wheel's throwing the abrasive down, it's throwing it straight down on the right side and then throwing it all the way over to the left side. So you kind of have a hot side on those electric machines. On the ride-on machines, you have what's called a parameter-fed blast wheel or a paddle wheel. So if you think of that paddle wheel on an old steamship in the Mississippi that's kicking along and back, that's the type of blast wheel that is inside the ride-on machines. Ride-on machines are generally used for warehouse and bridge deck work, but it's a bit more of an efficient way of propelling abrasive because it's doing it evenly across the entire width of the machine rather than being thrown from one side to the other.
Why can't you do that with the electric machines? Why do we have
we can do that with the electric machine. What you find is how you have to open and close that valve on a paddle wheel design takes a lot more time. It's not instantaneous like it is the electric machines. So when you're on a bridge deck and you're about to start the end of your pass, you have to start shutting your shot off 10, maybe 15 feet before you end to try and gauge it right. So when you're inside a home or an office building, it's really difficult to gauge what that distance to stop is or when to start shutting off your valve. And if you don't do it right, you end up blasting a hole in the floor at the end of your pass or as you're getting close to it anyway, or you haven't blasted enough at the end of the pass and it still needs to be reblasted. So when it comes to instantaneous shot on or off or having that valve open or closed, the electric machines where the operator's physically moving that abrasive control valve is a better setup.
And you said, I knew shot blasting steel and different things like that. Shot blasting the asphalt, I was not aware. I would have thought asphalt would have been a little too soft for that.
It can be. It's actually retexturing. So you're over time, just rain or when you hydroblast or high pressure water clean something, both concrete and asphalt do the same thing. It's where that water begins to polish the aggregate that's in it, and it actually becomes slicker than what it was before. So by using a very small shot and going extremely quickly, you're creating a micro texture rather than a macro texture on it. So you're able to just give the aggregate in there a little bit more amplitude to be able to have some more traction.
Okay, so this when you would just go and shot blast an older road to kind of give it a little texture so that it's not slick again.
Exactly right. It's commonplace in Europe. We don't do it a whole lot here, but it is a practice that's becoming more influential rather than just redoing all the roads all the time. And in some instances and applications, you just retexture it.
Yeah, asphalt. I mean, asphalt in Europe is very different. I mean, we even polish asphalt, and people look at me like I'm crazy.
Yeah.
Because I said polished asphalt. It could be other reasons too, but it's the idea is that I mean, you can polish asphalt, and it turns out, I mean, it's a really dynamic product too.
Indeed, it is.
But yeah, it's pretty interesting. No, I wasn't aware of a different paddle size, and that's a great visual for the old steamship. Works for sure. Perfect. But yeah, do you have anything else? I mean, I'm all ears for these. These.
I think we talked a lot about, and this is a concrete podcast, but we do manufacture machines that are different than the ride-on and the electric traditional blast track machines that we see all the time in the concrete industry. We manufacture machines specifically for steel blasting as well. So fleet readiness for the military, where they're redoing the decks of their ships all the time, and then petrochemical stuff as well, inside crude oil storage tanks, gas tanks, oil tanks, and then the roofs and walls, exterior shells of those as well. It runs on the same principle, a little bit of a different process, but we've got we manufacture a blast machine for every single application out there. If it can be blasted, we got a machine for it. That's for certain.
Absolutely. Probably got a machine for things you wish you hadn't blasted.
You're not lying, friend.
Yeah, this has been terrific, Levi. I really appreciate it. And, surface prep is one of the things where, there's just a lot of it happens, and then people don't realize why things are happening and what can do. Like the idea of grinders pushing things into slabs as opposed to shot busting, pulling things out.
Yeah.
A lot of in them being complementary processes. That's a great point. So no, I really appreciate that. That's a good way to look at it.
Yeah, Chad, thank you for the invite, dude. This is awesome. I love what you're doing. It's cool to get a lot of insight from different people in the industry and just kind of educate each other as a whole. I think it makes us better.
Yeah, it does. I mean, sometimes the more your customer knows, a lot of people get shy about that. They're like, if they know, they're going to pick me apart. But really, the more prepared they are for it, then you get expectations in the right place and explain the limitations. And I think if they come from the place of understanding what it's going to do, then, as a contractor, as a customer, as a general contractor, I think everybody's better off from it. So that's what we're trying to do here. And then you never know when you get that extra tip. There's a guy out there who's slapping his forehead now because he's had to grind out an overlap and he never thought of putting an extra inch in there.
That's exactly right.
So that guy, if he's doing it and he posts in there and goes, "Hey, I got that overlap thing and thanks a lot. You were 3 weeks late, but I know next time that's fun too."
That's right.
Perfect. Well, that's great, man. We'll probably come back to you again here soon. And, once we get you on the line, it's a matter of trying to figure out, how much more information we can get from you, because it's it just saves us time and money.
Yeah, man, I'll be readily available. You call, I'll answer, my friend. I appreciate you, Chad. Thank you very much.
Thank you, Levi. And we'll post a link to your information, and I'll get you set up on it when we do it.
Thanks for listening to This is Concrete. We look forward to you joining us next time. Be sure to click subscribe to get future episodes.